Welcome everybody. Today we're going to be talking about equivalent fractions. But first we're going to talk about our fractions. What is a fraction? What are the parts of a fraction? So if you remember, if we think back to that pizza example, a fraction is merely a part out of a whole. So we would take the fraction of 1/2, or half of a pizza. We're going to first talk about what the top and the bottom are called. So the top, if you remember from maybe before in earlier courses, this is called the numerator. So the top of the fraction is called the numerator. You should know this already. The denominator is therefore going to be on the bottom. So the bottom of a fraction is the denominator. If you think of the letter D, think of the word down. So down is going to be the denominator, so on the bottom. If you think of the word equivalent, so now we're going to put it together. We have the parts of a fraction. Now we need to talk about equivalent fractions, what that means. What does equivalent sound like? Equivalent sounds like equal. Okay, and if you think of equal, it's having the same value. So no matter what, our equivalent fractions will all have the same general value. They can all be simplified into the same exact form. So if you look at equivalent fractions, what they are, we can multiply the numerator and the denominator of a fraction by the same number. Remember, that's that word same, the same value, to find an equivalent fraction. So these are merely just multiples of each other. So if you look at 3/5 times 2 over 2. Now taking a look at 2 over 2, what does that simplify to? If you plug it into your calculator, 2 divided by 2 equals 1. Which means that we are multiplying by the number 1. And what's so special about multiplying by 1? The fact that we multiply by 1 means it doesn't change the value of the number, it just changes what multiple we're looking at. So 3/5 times 2 over 2, if we think about how we multiply fractions, we're going to multiply straight across. 3 times 2 is 6, 5 times 2 is 10, therefore we get 6/10. If we think about reducing, I'm getting ahead of myself, but we'll be doing this in a little bit, we do the backwards. When I divide 6 by 2, we get 3. Divide 10 by 2, we get 5. So therefore, we have an equivalent fraction of 6/10. Now we can do the same thing with 3 over 3. So let's take a look at this one. If we have 3 over 5 times 3 over 3, remember we're just taking a multiple. This will give us our equivalent fraction. What's 3 times 3? 9. Okay, and 5 times 3 is 15. So 9/15 is also an equivalent fraction, okay, because it's just a simple multiple of 3 over 5. So let's put this into practice. So list 2 equivalent fractions to each one given below. So remember, when we're listing equivalent fractions, we are finding just multiples of both the numerator and the denominator that are the same. So if we just stick to this 2 over 2 and then also 3 over 3, we're just going to multiply these. So 2/7 times 2 over 2. 2 times 2 is 4. 7 times 2 is 14. Therefore, 4 over 14 is another equivalent fraction. Another one we could do, remember, we can multiply by 3 over 3. When we multiply by that, 2 times 3 is 6, divided by 7 times 3, which is 21. If you can start to see a pattern here, we have 2, 4, 6, 7, 14, 21. Okay, they both progress at the same exact pace. That's why we're multiplying by this 2 over 2, 3 over 3, 4 over 4, and so on. They will always give you that equivalent fraction. So taking a look at number 2, we'll do the same exact thing. If we do 2 over 2, multiply through, 4 times 2 is 8. Okay, we're multiplying straight across. 5 times 2 is 10. 8/10 is equal to 4/5. And then so on. I can go even further and talk about our next one, which is multiply by 3 over 3. 4 times 3 is 12, divided by 5 times 3 is 15. Again, there's a pattern here. 4, 8, 12, 5, 10, 15, and so on. Okay, what I want you to do now is pause the video. I'm going to stop here for a moment, and then I'm going to go on. I'm going to show you the answers of these next 2 problems. Okay, have them all done, so let's check out 3 and 4. Okay, an equivalent fraction of 1/8 could be 2 over 16. I just multiplied top and bottom by 2. Another one could be 3 over 24. Okay? Another equivalent fraction I want to point out is the fact that we can do 10 over 80. Doesn't that reduce to 1/8? Absolutely. So there's another equivalent fraction. Another one, 100 over 800. Still equivalent because if you plug it into the calculator, you're still going to get the value of 1/8. It's the amazing thing about equivalent fractions. And lastly, 10/3, you can do 20 over 6. We can do 30 over 9, and so on. Pattern continues. The next idea I'd like us to discuss is let's work backwards. Let's take an equivalent fraction, or what we think are equivalent fractions, and use our skills to determine if they are. So the cross product property. This you may have heard this before. This is cross multiplying. So when we're given two fractions that are set equal to each other, AB equals C over D, we're just going to cross multiply. So we're going to multiply across. A times D is AD equals B times C. So they should be equal to one another. So if we take an example, 1/2 should be equal to 2 over 4. Now to determine this is true, we're going to use the cross product property. 2 times 2 is 4, and then we're also going to take 1 times 4. 1 times 4 is also 4. They're equal to one another, so therefore 1/2 and 2/4 are equivalent fractions. Questions? All right, moving on. Let's talk about reducing fractions. This is just the opposite of what we were just doing. So we just found equivalent fractions by multiplying. We're also going to divide. So in this case, we are going to divide the numerator and the denominator by the same number. Again, everything is by the same number to get a reduced fraction. If we say reduce, we mean reduce to lowest terms. That means we reduce until we cannot reduce anymore. So I'm always going to be looking for the most reduced form or the simplest form. So let's take a look at some examples to wrap up today. If we look at 2 over 10, we want a number that when we divide 2, we can also divide 10 by. It has to go in evenly. So let's take 2 over 10. What goes into 2? The number 2 itself. So 2 goes into 2, and 2 also goes into 10. I'm just going to divide by 2. Divide by 2. Remember that if we take 2 over 2, that's still equal to 1. So we're not changing the problem. We're just reducing it. 2 divided by 2, this equals 1. And then 10 divided by 2 is 5. 1/5 is equal to 2/10. But this is its simplest form because we cannot simplify it anymore. Taking this next one. 5 goes into 35 7 times. So therefore, if we divide top and bottom by 5, it must be the same number or you're changing the problem in its entirety. So 5 divided by 5 is 1. Divided by 35 divided by 5, which is 7, once again. So therefore 7 is an equivalent fraction of 5/35, but we've reduced it to its simplest form. Last one before I let you go on the last two. 7 is 6 over 27. Now this is a tricky one. Does 6 go into 27? No, it doesn't go in evenly. So therefore we got to look at a different factor. Factors are just numbers when multiplied together get a larger number. So the factors of 6, what are two factors? We have 2 times 3, right? Okay, does 2 go into 27? No. But does 3 go into 27? Absolutely. So why don't we divide by 3 on top and divide by 3 on the bottom? 6 divided by 3 is what? 2. Good. When we divide, 27 divided by 3 is 9. Can 2 divided by 9, can that be reduced any further? Nope. So we are in our simplest form. So this case, we couldn't divide by just one of the numerator or the denominator, so we had to divide by a factor of the two. So a factor is something we'll talk about a little later in the course. At this point, I'd like you to pause the video, and then when you're ready to check your answers for 8 and 9, feel free to play it ahead, but I would like you to try them now. Okay, ready to check your work? All right, very good. So let's take a look at 81 over 18. Let's take a look. 18, let's always work with our smaller number. It's going to be easier to look for. Does 18 go into 81? No. Okay, so let's take a look at it even further. What goes into 18? 3 and 6, 2 and 9. But I know that 9 goes into 81, right? It's 9 times 9. So let's divide by 9. Divide by 9, divide by 9. What's 81 divided by 9? We already said is 9. Divided by, what's 18 divided by 9? That's half. 9 over 2. Can it be simplified even more? No, it cannot be simplified, so therefore 9 over 2 is our final answer. Very good. And our last one, fairly easy one, 7 goes into both of these. So we are going to divide by 7, and we are going to get 3 over 4. And that's our final answer. Any questions? You can feel free to ask me. We're going to move on throughout the rest of the unit talking about fractions, and we'll talk about adding and subtracting fractions and also multiplying and dividing, even though you've gotten a taste for it right now. So today we've talked about equivalent fractions, we've talked about reducing fractions, and using the cross product property to check if we have equivalent fractions. Thank you for watching. This has been Mr. Korb. Have a great day and practice those problems.